I'm gonna quote Andy Dufresne from Sourcing Redemption. Hope is a good thing, one of the best things, and no good thing ever dries. So, hello guys, and let's start this chapter from where we left off. So, we got this error term here. This is the error term that we got. So, let's assume this as, let's consider as R. Okay. So, if we write R again, okay. So, R is given as y square plus m square x square plus c square plus 2mxc minus 2y mx minus 2yc. So we have to find like how this r is changing. Sorry, how this r is changing with the change in the values of m and c, because x and y are fixed and we cannot change it. So the only value that we can update are m and c. So we have to find like how r, that is the error term, is changing with respect to m and c. So for that we will find partial derivation. So before moving further, if you guys don't know what partial differentiation is, so I'll try to make you understand it as much as in layman term as possible. Partial differentiation, okay. So suppose you are a student and y is your marks, okay, marks in exam, and it depends on two variables. Let's consider this as x and z, okay. So x, maybe it is the attendance that you have in your class, attendance in class, and z is the daily revision, okay, daily revision of notes, okay. And we got to find out experimentally that y depends on x with the power of 2, and on z it depends with the power of 3, okay. So the actual equation that we got to find out is y equals to x cube, oh sorry, just a second, y is x square plus z cube. That is, your marks depend on the square of the attendance in the class and the cube of daily revision of notes, okay. So if we have to find like particularly how your marks is dependent only on the attendance, okay, so how we'll find out? We'll partially differentiate your marks with respect to the attendance in the class, okay. So if suppose we for partial differentiation we use this symbol as del y, okay, sorry, del y, just a second, del y is your marks, and del x, x is the change in your attendance. So how it's gonna affect? So if we know the differentiation, so it's gonna be 2x, and since there are no x term involved here, so it will turn out to be 0, okay. Similarly, if we want to find out how your marks depends upon daily revision of notes, so this term, that is x, there is no involvement of z here, okay. So this will turn out to be 0 because there are no z term, okay, and this will turn out to be 3z square, okay. Since the differentiation of any variable with respect to that variable is n into nx to the power n minus 1, okay. I hope you understand this. So if we want to find this equation again, okay, so just a second, let me copy this here slowly. R equals to y square plus m square x square plus, just a second guys, c square c square plus 2mxc, okay, and then minus 2ymx and minus 2yc. Minus 2ymx minus 2yc. Okay, so we have to find like how this r is changing with a small variation in m and with a small variation in c. So we'll partially differentiate r, that is our error term, with respect to m first. Okay, so if we partially differentiate r with respect to m, so here there is no involvement of m, so this will turn out to be 0. Okay, this will turn out to be 2m, and this x square will remain same. Okay, here c square there is no involvement of m term here, so this will turn out to be 0. And again see here's just one m, so this will turn out to be a constant. So 2xc minus, here is also just 1m, m to the power 1, so 2yx, and here we do not have any m here, so this is the equation that we'll get. Okay, so if we write it further again, removing the 0 term, del r upon del m equals to 2m x square plus 2xc minus 2yx. Okay, this is the value we have gotten. Okay, and with respect to c, if we want to find out del r, that is our intercept, del r equals to del c. So again here we do not have any c here, so this will turn out to be 0. Okay, again here also we do not have any c term, so this will again turn out to be 0. Okay, I hope you guys understanding. Plus 2c, because here we have c square. Okay, c square, this time is c square. Okay, and again here we have just 1c. Okay, so this will turn out to be 2mx. Okay, and then here we do not have any c term here, so this will turn out to be 0, and here we have just 1c, so this will turn out to be minus 2y. So if I write down again, minus 0 minus 2y. Okay, I hope this is clear. So if I write it down again, this thing, I hope you guys are following with me. It's not that difficult as it seems. It's literally very easy and basic. 2c plus 2mx minus 2y. So this is the dependency of r on the c. So if r, like how much r, that is the error term, is changing when we change c a little bit. Okay, so like we will continue this chapter discussion in the next chapter. I hope till here this thing is clear. See you guys soon.